All right, last homework assignment, we started vectors. We're moving in two-dimensional motion. And we just added vectors directly. We did an x component, we did a y component, and you found the resultant. Then you found the new angle. This is just a review of geometry, so we didn't spend much time on it. It was pretty straightforward. What you did in the last assignment was review these functions here. I have cosine of my angle is the x value over the r value, the x component over the resultant, which you all know as adjacent over hypotenuse. And I'm going to get away from using those words. Sine of theta is y over r, or opposite over hypotenuse. And tangent of theta is y over x. So let's review x and y and r real quick. So here is my coordinate system. This is the x-axis, so any motion horizontally is considered an x value, an x component. This is my y-axis, so any movement vertically is considered my y component. You all know that as adjacent and hypotenuse. I'm going to get you away from that and call it x and y. Adjacent and opposite. This is the hypotenuse, but I'm going to call it the resultant because it is the result of moving this way, then this way. We call it the resultant. So you guys did that in the last assignment. I gave you the x value and the y value. You found the resultant and the new angle. Now on this assignment, I'm going to give you the resultant and the new angle. You need to find the x value and the y value. And later on, I'm going to give you several resultants, and you need to find the total x value, the total y value, and the new resultant, because it's a new line. And that includes the magnitude of the line, the length, and the direction. All right, so let's do a little bit more review. If I move this way, this is east, and east is positive. I'm going to put that there because vectors have a direction, and in physics we indicate that with negative or positive. This way is south, and that is negative. This way is north, and that's positive. And this way is west, and that is negative. So when I say 5 units west, that would be a -5 in that direction. If I say 6 units south, that would be a -6 in this direction. So south and west and north and east equate to a positive or negative value. That's something you have to get used to. Well, if you all know these equations, cosine of theta is x over r, sine of theta, tangent of theta. I can rearrange these equations to solve for the x and the y. And when I do, I get x is equal to r cosine theta, and I did that by multiplying both sides by r, multiplying everything by r. R cancels out and it shows up over there. And so y is r sine theta, r sine of theta gives you y. And the new angle, for us, I mean there's other ways, for us we're always going to find the angle between the resultant and the x-axis. So if I move this way, it would be this angle. If I move that way, it will be that angle. If I move this way, if I go down this way, it'll be this angle, and if I go down that way, it'll be that angle. So it's always the angle between the x-axis and the resultant for us. I want to keep things kind of uniform because this is a review, and for some people it's new. So whenever I find an angle, theta, this is the angle, these are the angles that I'm going to solve for, so you have to keep those in mind. All right, let's go to what we did today. This is the sheet, this is what it looks like, and I will put a link to this document on the calendar, so you guys, those of you who weren't here, you can print it off and follow along. All right, so the first one was pretty easy. It says 7 units at 43 degrees south of west. Well, I'm going to first give a visual, then I'm going to take the visual away. So I'm going to put a coordinate system. And I know I'm south of west in that third quadrant, so I want to make sure at least that third quadrant is on this grid. So this is west, this is south, this is east, and this is north. And I'm 43 degrees south of west, so I'm somewhere down in here. Somewhere down in there. This is a sketch too. And so when I need to do, what I need to do, or you need to do, is you need to find the x component, and we always add tip to tail, and the y component. The resultant goes from the tail of the first to the tip of the second, because you always want to know how far are you from where you started. So this is where you started, this is where you ended, and that's how you draw the resultant. So I need the x component and the y component. Well, let's see. This is 7 units, and this is south of west. South is negative, I'm going to stick a negative sign there. And west is also negative, and I'm going to stick a negative sign there, because these x and y components have directions. I want to make sure I put those directions in the answer. So, let's see. X is our cosine theta, which is 7. Cosine of 43. So x is, and I have these worked out, that way I don't have to spend time on my calculator. Let me find that sheet of paper. I got x to be 5.12, and it is negative because it's west. So x is done. Y is our sine theta, which is 7 sine 43, and y is equal to negative 4.77. Negative because south is negative. Alright, so it's pretty straightforward. The second question asks you to do the same thing. Find the x and y components. And if you turn the page, there's some more practice, and it should be review. And again, 10 units at 87 degrees north of west. Find the x and y components. And again, our sine theta or our cosine theta. Just some practice and review. Now, the second part is what I call compound vectors. I'm not sure if that's an official name, but that's what I call it. So this is the addition of 2 or more resultants that's going to yield one big right triangle. Let me show you what I mean. So not only do I have to figure out where I'm going, I got to find the new direction, and I got to find the new magnitude. So I'm going to sketch this. Pretty soon I am going to take this grid away, and you won't, because you really don't need the grid to do this. So let me put a coordinate system on here so we can get a visual. And I'm east and north of east, so I know I'm in that first quadrant. So I'm going to put that key in on that quadrant on this graph. So I know I'm somewhere up in here. This is north, this is east, this is south, and this is west. So it says you move 7 units east, and this is a sketch, so I know I'm like 7 units that way. And then it's 8 units at 30 degrees north of east. So what you do is you put the tip of this arrow is your new origin. I'm going to turn 30 degrees north of east and go 8 units. So that's about 30 degrees north of east right there. And I'm going to go about 8. And of course this is a sketch. So this is where I started. This is where I ended. So what you need to do is find this new vector, how long it is, and at what angle it is. And it looks kind of challenging, but really it isn't, because can you visualize that what you've done is one big right triangle? Can you see it there? One big right triangle. So if I can figure out what that value is and that value is, I can use Pythagorean theorem and figure out what that value is. So let me show you how to do it. This is very rudimentary, it's very basic. There are many other ways, but I want to try and keep it simple so you understand what's going on. So what I like to do is a table. I'm going to use a pen, that way I can squeeze more in here. I like to do a table. So there's a table. And again, once you get used to this, you'll even be able to get rid of the table. But that way I can visualize and make sure that I have done everything. I like to do a table. And then there's X and Y. I'm going to put these values here. And then I'm going to evaluate each movement. It looks like I moved twice. So I'm going to do number 1 and number 2. So let's evaluate the first movement. The first movement is 7 units east. And that's all on the X-axis. So I'm going to put underneath the X on the table 7 units. I didn't move in the Y direction either way. I didn't go up or down. I just moved to the right. So I'm going to put a dash. What that does is that shows me that I did look at that component, I did evaluate it, and there is nothing there. Now I'm going to go to the second motion. Well, the second motion is interesting because I moved this way, then I moved this way. I moved this way in the X, I moved this way in the Y, and that's how I created this line right here. And there's my angle for that one. So if I can get this length here and that length there, I can add it to my table. And that's easy. That's sine and cosine. So to get this value right here is r cosine theta. R, which is 8, cosine of 30 degrees, gives me my x value. And what you end up getting is, let me find that work. What you end up getting is 6.92, and the y is r sine theta, and what you end up getting there is 4. Then we need to add them all up, because now I know this number, I know this number. I'm going to add them together to get that whole length, and you get 13.92. And then I know this number here, which is 4. Now I have the makings of my big right triangle. Well, getting this line is now easy, because r is the square root of x squared plus y squared, Pythagorean theorem. I plug in my numbers, square root of 13.92 squared plus 4 squared, and when all is said and done, you get 14.48. One thing I didn't do, which you'll need to do, is very important, is pay attention to the sign. East is positive, so 7 is positive. North is positive, so 4 is positive. And east is positive, so 6.92 is positive. So I'm going to add all those together. That's how I got 13.92 and 4. You trust me, you will run into some negative numbers. And if this number were negative because it ended up going west, then you would subtract those. Since they're both positive, you add them. So 13.92. And I already know that my direction is north of east. How do I know? Because y is positive, that's north, and x is positive, and that's east. So I already know I'm north of east. I need to figure out the new angle. What's that new angle? And again, we did this on Wednesday. Theta is inverse tangent of y over x, which is inverse tangent of 4 over 13.92. Make sure your calculator is in degrees, and you end up with about 16 degrees. So I am 14.48 units, and I'll write that there, at 16 degrees north of east. So there is the total answer. It says resolve each vector to determine the resultant vector, magnitude and direction. There's the magnitude, 14.48 units, and there's the direction, 16 degrees north of east. I'm hoping this is a review. Why don't we, so here's one here, there's 10 units, 56 degrees south of west, and then 5 units north, 8 units north, then 6 units at 60 degrees south of east. Again, you do your table, you can sketch it out if you need to draw it. And then on the last page, I take the grid away, and I just give you the movements. Here's my first movement, 7 units at 43 degrees south of west. My second is 10 units at 87 north of west, my third is 6 units at 60 degrees south of east, and my last is 9 units north. Well, I'm running a little low on time, so go ahead and try this. Come and see me for the answers, and I wish you luck.